So welcome to another digital design. In this case, we have the project number 5, Rainbow Light. For building this digital design, we have the second section of Tinkercad, which is circuits. Today we are going to work with this section. And then when we click on this second section, will take us to a new digital design. So we're going to click create new circuit, and from here will take us to our workspace. So the first thing is changing the name of our project. At the top left you will see a name that Tinkercad is giving us, so we just change this one to project number 5. This one is gonna be Rainbow Light. After that, the next thing is bringing the first component to our workspace. And this one is the Arduino Uno. We are going to be using this microcontroller for our project. And by clicking, we can drag the component to the center of our workspace. We will need as well for this design a breadboard. In this case, we are going to use the small one. So under the microcontroller, then we bring our LED RGB. Is a component with 4 connections, 4 pins. And let's take a look to this component. If you see, the first pin is the red one, the one that is going to give us this color. This needs a resistor, so we will need 1 resistor. Also, we have a third here. Let me check this first. Is our blue, and our third one is our green. So in here we have the 3 colors, basic colors that we are going to be working with. And the next thing is checking the polarity, the connection, if it's cathode or anode. Some of these LEDs, RGBs, are going to be connected to, like in this case, to the negative or cathode, and some others to the positive or anode. We have to be very careful when we buy a component. In this case, it's going to be our negative cathode. Now let's bring the last 3 resistors. So resistor 1 for red. We will need another resistor for green and another for blue. We can close this search area, so we will have enough space for building our project. In this case, we are changing the value of our resistors. The colors, they work well, or LEDs, they work well with 220 ohms resistors. So the first one, let's take a look to the resistance, is 1 kilo ohm. This has to change to a smaller value, 220 ohms. The same for second and third. Let's change to 20 ohms to 20 ohms. So that way we have our resistors ready. The next thing is bringing our RGB to the breadboard. So in here we are bringing this, and let's place this on the column A. So at the bottom of our breadboard, and let's use column A, and the rows are gonna be 14, 15, 16, and 17 for connecting our resistors and wires. So let's take a look to the left pin. This one is a red color. We need a resistor for this connection. So we're bringing this resistor and placing it on row number 14. And then this one is going to be connected between row 14, the first part here, and the second part is crossing the bridge because in here, well, we don't have energy. We don't have a connections as well. So the second pin is gonna be connected on column F, the same row 14. The next pin is the cathode. This one is the connection to our ground. This connection or this wire can be connected from column E and directly to the microcontroller. So we can use this ground, this cathode. So we change this to blue to indicate that we are working with a cathode. By clicking twice on the cable, we can bend this cable by using this dot that will show when we click twice on the cable. The next is the blue. Blue needs another resistor, so we bring this one and we're going to place it next to the cathode, protecting the blue color. Next is green. And we have our first step before connecting the resistors to the microcontroller. So in here we are going to look for the first color, which is red. Red will start the connection from column G and the same row 14. In this case, we are going to look for a connection on our microcontroller that has a tilde. Tildes are numbers that have a line here next to it. So we have, for example, 3, 5, 6, 9, 10, and 11. Those are special numbers, PWM. They are going to handle many numbers. Since we are going to read different colors coming from the RGB, these colors are represented as numbers going from 0 to 255. When we reach the 255, we can see the color, in this case blue, red, or green. And that is the reason we are using these numbers with a tilde next to its number. So the first thing is connecting the red color. So for this one, we will use the number 6, since 6 has a tilde. So the wiring will start on G all the way to number 6. We release the mouse, and then by clicking again, we can change the color of our cable. Since this one is red, let's change this one to red, and then double click on the cable so we can bend and we can see the number in here. So this one is a red. Cathode is connected. The third one is gonna be blue. Blue is our number 3. So we are going to look for blue starting from G as well, column G, and looking for number 3. In here we have our blue. and we change this one. We can bend this cable again so we can see the number. And our next color is gonna be our green. Green is the same on column G, and we are going to look for the next number that has a tilde. In this case, we are going to use the number 5. So number 5 is connected and changing to green. So that way we have the connection ready. Also, we can modify the cable, the shape of our cable, bending so we can see the connections there. So that way we have our digital design ready. The next thing is typing our code. For that, we are going to use the section at the top right, which is code. In here, Tinkercad is going to give us 3 options. We have options for blocks and text, Since we are using C++, we are going to click on text and we will continue. Tinkercad is giving us already code, which is a sample there. So we are going to erase it because we are typing our own code. If we use the icon at the top left in here, we can zoom to fit. So we will see the project while we are typing. There are some connections here, some pins that we will need. So it's important to see our project there. The first part of our code is declaring the variables. In here we have 3 variables and these are the colors. When we declare variables, we start with a data type. In this case, it's an integer. So we type only int. You will see that the colors are changing to purple. So this one is a data type. And in here, we need to give a name to the first variable. In this case, was our red. So we are going to describe it as red pen. In C++, when we type 2 words, the way we are going to divide is by using a capital letter between these 2 words. So the first one is our red pen. So we have already the first variable. In here, we need to check which one was our pin on our microcontroller. And this one was the number 6. It's the same that we are typing here. And then semicolon for closing this first variable. If we move our cursor a little bit to the right and we add 2 slashes, we can add comments to our project, our code. In this case, the first part of C++, we can say that this is a variable or variables declared. This is the first part. int, we can copy and paste this first declaration, and then we are going to look for the second connection, and in this case, we are going to look for green. Following RGB, which is red, green, and blue. So our green pin is a connection in our microcontroller to the number 5. So we declare green pin as number 5. And the last one is our blue. So in here we will give the name blue, and the connection was number 3. That way we have the first part of C++ ready, variable declared. The next thing is the function. In this case, we are going to start with void setup. Void setup is our first function, and in here we need to declare the constants. We have 3 colors. The 3 are outputs, and these ones are declared as pin modes. Pin modes, they are going to ask for 2 things: the name of our variables that we gave at the beginning of the code. So we can bring the first one, which was red, and then the program will ask for the constant, which are outputs. And we can copy and paste the same line 5, since are gonna be exactly the same two more. So in here, the second pin mode, that goes to green. So the only thing that we are going to do here is just replacing the name of our variable to green. And then a third one for blue, following the same pattern as RGB, red, green, blue, red, green, blue. These ones are outputs. So basically, this is all what we are going to include in void setup. Void setup, or every function, starts with a bracket. So in this case, we close with another bracket our first function. The second function is a void loop. Void loop, in here we are going to include another function, and this one is for actually reading colors. There is an RGB chart that we can use for adding more colors to this project. But we're gonna start first with the basic, which is red, green, and blue. The function that we are gonna be using in C++ is setColor. setColor will read the 3 numbers, like this one, 255, 0, and 0. This is a color, and since we started with the maximum number 255, so the color that we are going to see as first is red. Since it's at the maximum, we are going to see the red color. Green, we won't have green. Blue, we won't have blue. So that is gonna be our 255, our red. Then we have another setColor for the second connection in our project. So red has to be in 0, no red. Green is gonna be maximum, and blue, we won't have the blue color in this line, only green. The next thing is gonna be for the last color, no red, no green, but blue. And in here, we can type comments about the type of colors we are seeing. After this line, we can continue adding more colors, but since we declare only red, green, and blue, let's start first with these 3 colors. Since void loop includes only these set colors, this function, so we close with a bracket, because the next one is another function that we are going to be using for actually displaying the colors and matching the colors with the pins in our microcontroller. This next line, 14, is called subroutine. This subroutine includes as well a void and then the set color. In here we are going to open a parenthesis for starting with the integers for reading first the red color, then the second one that we declared that was green, and last blue. So in this case we have as a comment, we can tell that this one is a subroutine and is for reading the colors connected to those specific pins in our microcontroller. From there, we are going to open a bracket and then we will continue with the last few lines of code, which is the analog reading. When we type analog write, which is another important instruction for C++, we will read the pins from the microcontroller. In this case, we are gonna start with the red pin, the one on line number 5. So we can copy and paste the name of our variable, and we can add to the analog write. In here, we are going to indicate that this pin will read red color. We close this line 16 with a semicolon. And basically, we are going to do the same for the other two colors. The 3 are analog writings, so on line 17, we will do the same, but bringing the green variable, green, and in here we'll read green. Line 18 is gonna be another analog write, this one for our last color, which is blue, and we'll read blue. Now that we are reading the 3 colors present in our digital design, line 19 closes with a delay. Delays are the timing, and it's gonna be the time between the changing of one color to another. So in here, we can use 1.5 seconds. These ones are milliseconds. This program reads seconds and milliseconds. It's important to mention this. We can leave 1.5 minutes, and that is gonna be plenty. We can modify this number if we want a faster blinking or slower. Then our subroutine, this section of our code is going to close with another bracket, the one that we started here, after the void set color or subroutine. And then we will be able to test our project to see which colors are present there. By going to the top right, we start the simulation, and then we will be able to see red, green, and blue. Red, green, and blue. Those are the colors that we have in our digital design. And this code will apply for cathode. There are gonna be some other RGBs that are coming as anode. We are going to modify this code a little bit, just adding 3 more lines of code so we can read this anode RGB. Where we are going to add these 3 lines, so basically is above analog write. Between line 15 and 16, we need to open a space. And then, since we are not going to use these lines for this particular project, we are going to add a // so the program won't read them. We add, again, red equals. Red, if you want to see red on this RGB, so you have to type 255, which is the maximum number for the color. And then to subtract red, closing with a semicolon. The same thing is gonna be for green. Green, the maximum is 255, and we subtract the variable green. And the same is gonna be for blue. Blue is gonna be equals to the maximum number minus blue, semicolon. These three lines are gonna be always used when we have RGBs as anodes. So next to, we can add another comment. Uncomment these three lines for anode RGB. So it's important to have these three lines there. And then if we start the simulation, you will see that actually the code is not affected because we have the slashes at the beginning. So basically this is the code. One last thing that we can add to our project is on line 12, our students can modify by adding lines between 12 and 13 more colors. For example, I will open this line 12 and 13, adding another set color and opening a parenthesis. And let's see, I want to add 255, 255, and 0. I mean, I have my RGB chart and I want to see what color is this 255, 255, 0. So by starting the simulation, we will see red, green, blue, and then our new color, which is yellow. So in here, we can invite our students to add another comment and placing this as yellow. This is another innovation that they can use for this rainbow light.